My name's David Glass, and I'm going to be taking this seminar on studying mathematics as a Christian. Now, you might wonder why we have a seminar like this arranged on this topic. What exactly does mathematics have to do with Christianity, you might ask? You might think that they're completely separate, but what I want to do in this seminar is to try to show that there are important things to think about from a Christian perspective when studying mathematics. There could be many different reasons why somebody would be studying maths at university. You might study it because you really want to work in mathematics in the future, or perhaps you would like to teach it at school in the future, or perhaps you just have a real passion for the subject. Or maybe you're not sure what you wanted to do and you were good at it at school or enjoyed it and you find yourself studying it. So there could be a variety of reasons. What I want to suggest from the outset is that whatever our reasons are for studying it, really our motivation in our study should be to glorify God. So in Colossians we read, "Whatever you do, work at it with all your heart, as working for the Lord, not for human masters, since you know that you will receive an inheritance from the Lord as a reward. It is the Lord Christ you are serving." And so whatever we do, whatever line of study we're in, whatever line of work we're in, we should do it for the glory of God. We should do it to serve Christ. And this applies to mathematics as well, of course, as to other subjects. Everything we do should be for God's glory. Sometimes in the Christian world, we have this sort of division between the sacred and the secular. We imagine that there are certain types of spiritual things that we can do, such as becoming a missionary, and other secular things like studying mathematics. But actually, from a Christian point of view, everything is to be done to God's glory. And so what we need to do is to do what God has called us to do. And for some people, that may well be becoming a missionary. For others, it may well be studying mathematics. The key point is that together we all worship God in the different roles that He has given us to do. So that's the first, I suppose, and the most important thing in terms of studying maths as a Christian. That it's not just a matter of working harder if we really enjoy it or because we need to, but that we should work at it because we want to bring glory to God. However, I also want to think about studying mathematics from a Christian perspective in terms of the subject matter itself. Now, you might be inclined to think that in terms of the subject matter, it's neutral. It doesn't really matter whether you're coming at it from a Christian perspective, an atheist perspective, or whatever. It's just mathematics. You're all doing the same mathematics. And of course, in a certain sense, that's true. We are doing the same mathematics, but this is also true of other subjects as well. So if we think of physics or other sciences, of course, we might be doing the same things as other people, but our Christian perspective should give us a different way of looking at the subject. So in terms of physics, we might think, well, how does that relate to creation? And so although we mightn't be studying creation in our physics lectures, nevertheless, as Christians, when we're thinking about physics, we would want to think about it in the context of creation. So it's only when we take a step back and think about the subject as a whole that we then maybe see the relevance of a Christian viewpoint. And that's the same for mathematics as well. And I want to look at that in terms of three different aspects. The first concerns the very nature of mathematics itself. In a sense, what is mathematics about? What is its subject matter? And that's perhaps the most abstract part of this talk. And if you get through that, hopefully the rest will be okay. The second bit is what I'm calling here the argument from mathematics, that mathematics actually provides us with an argument for the existence of God. And finally, then, to look at Christianity and mathematics, the role that mathematics had in terms of the scientific revolution. So let's start off with the nature of mathematics. Mathematics relates to other disciplines. So for someone who's studying physics or chemistry or biology, for example, they will need to know a certain amount of maths. If they're doing physics, quite a lot of maths. So mathematics is used in these subjects to model how the world works. But it's also used in other disciplines within computer science. So mathematics really plays a very important role in the fundamentals of computer science and also in engineering. So here we're moving beyond the description of the natural world to thinking about the world of engineering and how we go about constructing things in the world. But it also applies in the social sciences. So there's a lot of mathematics in subjects like economics, for example, looking at decision making of human beings and the interactions between them, as well, of course, as the financial side of things. And even in subjects like philosophy, mathematics can play a role. So when it comes to thinking about reasoning and how we think about evidence or explanation, how we deal with uncertainty in our reasoning, how we draw conclusions based on the evidence available to us, all of this could be included in philosophy, and mathematics can be used in that context. So mathematics is really quite different from other subjects, or at least from many other subjects in this respect, because physics, we can think about its subject matter in terms of the physical world. We can think of the other subjects too in terms of their particular subject matter, but mathematics can be applied in a whole range of different subjects, and it certainly is. I mean, I've had the privilege of being able to work in some of these different areas. Just to take one recently, if we look at biology, for example, in the context of COVID-19, we can look at mathematical models to describe how the virus spreads. So it has a lot of applications. And so mathematics is usually divided into two branches: pure mathematics, which studies mathematics in isolation from its applications to the world, and applied mathematics. So the examples I'm giving here are of applied mathematics, and we'll come back to that later in the talk. But in this first part, I'm trying to think about mathematics itself and what its nature is. So what is mathematics about? Well, here we have Pythagoras' theorem. So we're all familiar with this from school. If we have a right-angled triangle, then the square of the hypotenuse, c squared, is equal to the sum of the squares of the other two sides. Now, this is a theorem in Euclidean geometry that we're all familiar with. So what can we say about Pythagoras' theorem? Well, first of all, it's to do with truth. Okay, this is not just a description of something that happens to be true, but it's a study of the properties of right-angled triangles. And so when we prove the result, we're actually demonstrating something that is true about right-angled triangles, and it's true about all right-angled triangles in Euclidean geometry. The second thing is that it's about necessary truth. It's not just something that happens to be true. So for example, if you're studying physics, you study aspects of the world that happen to be that way. And it might be amazing that they happen to be that way, but in principle, they could have been different. Maybe the laws could have been different, or particular facts about the history of the universe could have been different. Or think about truths in everyday life. If you think about your own life, there are decisions you have made, like the decision to come along to this seminar. Now, that wasn't necessarily going to be the case. You could have decided to do something else. So although it's true you've come along to the seminar, it's not necessarily true. It just happens to be true because you decided to come along to it. But mathematical truth doesn't just happen to be true, it's necessarily true. It couldn't have been otherwise. So if we think about this, about Pythagoras' theorem, it's not just that it happens to be true for some right-angled triangles, it's necessarily true for all right-angled triangles in Euclidean geometry. And so again, when we've got the proof, that demonstrates that it's true in general and not just in a particular case. I've already been referring to the notion of proof, and this is something that is really very important, of course, in mathematics. It's that we can prove theorems like Pythagoras' theorem. And we do that from certain axioms and we go about it in a rigorous way. Now, there are different strategies for proving things, and there are many different proofs of Pythagoras' theorem. But the point is that if you follow these proofs step by step, then they demonstrate the conclusion beyond doubt. Okay, so that is part of the nature of mathematics. So it's a rigorous way of demonstrating the truth. And this is different from science. So science doesn't work by proving things in this sense. Science works by gathering evidence in support of a hypothesis or a theory. And so mathematics is really quite different from physics, for example, in that respect. Now, these things are really quite significant. So for us as Christians, then I think we should already be seeing some connections here. The emphasis on truth. Well, as Christians, we would want to say that in some sense, and this is kind of what we're going to explore, that all truth is God's truth. God is the creator of the universe. Where does mathematical truth fit into that? And also when we think about necessary truth, we think about things that couldn't have been otherwise. Now, when we think about the created universe, it could have been otherwise. So again, where does this fit in? So as Christians, we should value the truth and be seeking after the truth and trying to find the truth. And this is what mathematics is all about. And proof is important too, because that's how we find or demonstrate the truth in mathematics. And then finally, a question here about whether these truths we discover are invented or discovered. So what exactly is mathematics? I mean, I've sort of described it as if there's a truth out there to be discovered. And that's the way many mathematicians view it. Others have tried to argue that mathematics is really about invention. So when we come up with a new result in mathematics, a new theorem or a new proof, have we invented something or discovered something? And I think it really is tempting to think that mathematics is about discovery. It's just as you imagine someone who's exploring the physical world and makes discoveries that people didn't know before about the physical world, so mathematicians make discoveries about the mathematical world. And so many mathematicians view it in that way, although that's a controversial subject, and I'm not going to explore that in further detail here. Well, what about mathematical entities? So this does relate to the question that we've just been looking at, I suppose. Do these mathematical entities really exist? So let's take some mathematical statements like 2 plus 2 equals 4, 3 is greater than 2, or we could think of the numbers 2 and 4, that there is a number that is greater than 2 and less than 4, the number 3. Or prime numbers. So mathematicians know that there are an infinite number of primes. That has been proved, it's been demonstrated. Now, what is the nature of these numbers? Are these things that exist? And if so, in what sense do they exist? Now, let's just try to make a distinction, because this might seem a bit abstract. What are we talking about here? We're not talking about numerals. I mean, the numeral 4 obviously exists. And in fact, we have different numerals, don't we? We've got Arabic numerals, like on the screen here. We have Roman numerals. So there are different numerals, and those obviously exist. But what about the number 4 itself? Does the number 4 exist? Of course, we can have 4 objects. We could have 4 apples sitting on a table. We could have collections of 4 things of all different types. So we can have groups of 4 things in the world, 4 physical objects. But here what we're asking is whether the number 4 itself exists. Now, if it does, one way of thinking about its existence would be to say that it exists as an abstract object. Okay, so we've got all these concrete objects in the world, like this chair that I'm sitting on. It's a concrete object, or a tree out in the garden is a concrete object. But mathematical entities like numbers, and we could also include sets and functions and various other things in here as well, The claim would be that these are abstract objects. So they exist just as real, perhaps more real, some would argue, than concrete objects, but they don't exist in the physical universe of space and time. They exist outside space and time. This idea is called Platonism, and it comes from the Greek philosopher Plato. And according to him, mathematical entities would have existed as these abstract objects. In fact, these abstract objects, and it's not just mathematical objects, there would have been others as well, they in a sense are more real. They are the true reality. The concrete objects in our world are just the shadows of the true reality. The alternative viewpoint is called nominalism. Or at least one alternative viewpoint, and it denies that any such entities exist. There are no such things as numbers. Now, you might find this debate a bit odd and rather abstract, but let's persevere with it a little bit further. But why would anybody think that numbers actually exist? In addition to there being 4 apples on the table and 4 chairs around the table and 4 legs on the table, why think that the number of 4 itself actually exists? Well, one reason for thinking that might be to claim that there are true statements that we can make about the number 4. It's the sum of 2 plus 2. It's an even number, and so on. So we could make various statements about the number 4. So it has these properties. And also, when we think about numbers and about mathematics more generally, it plays a very important role, as we'll see later, in the description of the universe. Mathematics is involved in a fundamental way in thinking about the physical universe we live in. And so many people have claimed, for these kinds of reasons, that this really important role that mathematics has gives us reason to think that these entities exist. And furthermore, when we talked about discovery, again, the idea here would be that if you're discovering something new, something that other people didn't know before, well, then you're discovering something that is really there, something that exists, some new property of numbers, or the fact that somebody demonstrated there were an infinite number of primes. So that's one. Those are some of the sorts of reasons for thinking that mathematical entities might exist. What about nominalism? Well, nominalism would be the idea that there aren't any such entities. And so some people might say we should think of numbers more like figures of speech, for example. So when we say that one team destroyed the other, we don't literally mean that they destroyed the other, but we understand the meaning of that statement. It's true, all right, but it's a figure of speech. Or when we say it's raining cats and dogs, again, it's a figure of speech. It may well be a true statement, but it's a figure of speech and is not to be taken literally. And so some people would apply this approach to mathematics. So how should we think about this from a Christian viewpoint? And I'm not going to take a particular view on this question, but just to look at some of the options that there are for Christians. But first of all, let me just think about how it relates to materialism. So the materialist believes in the existence of the physical universe. And we would normally think of materialism being the idea that there is nothing beyond the physical universe. But if there are mathematical objects outside space and time, that does take us beyond the material universe. And so arguably mathematics, if it requires the existence of these mathematical entities, does seem to be in conflict with materialism. But mathematical objects might also raise a question for Christians. I mean, if the number 4 exists outside space and time, and presumably it has always existed, I mean, it can't just have come into existence at some point, then that raises a question for us. For if it exists, did God create it? Again, in Colossians, we read that for in Christ all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things have been created through him and for him. He is before all things, and in him all things hold together. So a wonderful statement here about creation. And it's not just the earth, it's about things in heaven and on earth. It's not just visible things, it's visible and invisible. It's whatever exists. All things have been created through him and for him. So if numbers exist, or other mathematical entities, they might seem to cause a problem here because they must always have existed. There were always three members of the Trinity. So does that suggest that the number 3 has always existed? But then, are these truths not independent of God? Okay, how could God be the creator of them? You see, the idea in Christianity is that God is uncreated. God is what the theologians would describe as self-existent, and he's independent. He doesn't depend on anything else for his existence. But actually, Platonism claims that mathematical entities are like that too. They exist, but they exist eternally. And they have no beginning and no end. And they are independent of other things. They don't require on anything else for their existence. And so the uniqueness of God in being self-existent might be undermined by this idea of mathematical truths. So how are we to think about this? Well, let's now recap where we've got to. If you're still following this discussion, and admittedly this is the most abstract part of the talk, this discussion about whether numbers exist. So there are two answers to this. Yes, numbers do exist. Well, how do they exist? One approach to this is the Platonic one that we've already described, that they exist outside time and space and independent of God. But we've seen that that raises a problem for God as the creator of the universe, because then these numbers exist independently of God and are eternal with God. Going back to the other branch, of course, we could deny that numbers exist. But there'll be a lot of disagreement about that, of course. And if we do, well, then we don't run into any problem. So that's one option, is to say that numbers don't exist and embrace nominalism. But probably the main viewpoint that has been adopted by Christians is an alternative one, and that is to say that yes, numbers do exist, but they don't exist in the Platonic sense of being outside space and time and independent of God. Rather, they exist as thoughts in God's mind. Okay, and this is known as divine conceptualism. So when we're studying mathematics, the claim here would be that the subject matter is something that does exist. Numbers and other mathematical entities do exist, but they don't exist in the physical world, and they don't exist as abstract objects independent of God. Rather, they exist as thoughts in God's mind. And so, in a sense, when we're doing mathematics, we are thinking God's thoughts. So that is probably the main view. It's not the only view that Christians have taken on this subject. And at the end of the seminar, I'll provide some resources that you might want to look into to explore this topic further. Okay, so let's move on from that fairly abstract first part of the talk to now look at how mathematics might provide a pointer to the existence of God. The Nobel Prize-winning physicist Eugene Wigner wrote an article called The Unreasonable Effectiveness of Mathematics. And in that article, he said that the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. The point here is that mathematics is used everywhere in the study of the universe, and in particular in physics. We've mentioned this already in the talk, but when we look at modern physics, it is so thoroughly mathematical that you couldn't study physics without studying mathematics, at least to some extent. And many of the real breakthroughs in physics, and this has been the case for hundreds of years, have come about as a result of developments in mathematics. But the question is, why is this the case? Why is this abstract subject that we've just been talking about mathematics, why is it so appropriate for describing the world that we live in? Of course, if you're used to studying physics, you've probably come to take this for granted, but it wasn't always that way. It certainly wasn't taken for granted in the past. And so the question is, why? Why can the world be described so effectively by mathematics? To take an example of this, consider the work of Peter Higgs, another Nobel Prize winning physicist. So he was working on mathematical problems in particle physics back in the 1960s. And as a result of this work, solving problems in mathematics, he predicted the existence of a new particle, which became known as the Higgs boson. Now, this particle, it turned out, played a very important role in particle physics. And so for years, for decades, scientists, experimental scientists, were looking for this particle. It wasn't until 2012 that scientists at CERN found strong evidence for it. Up until that, they had searched, but they had searched in vain. The experiments hadn't turned up anything. But eventually they found evidence for it, which was later confirmed. They had indeed discovered the Higgs boson. And then Higgs won the Nobel Prize in 2013. Now the question is, why is this the case? Why is it that somebody working in his office, sitting doing mathematics, is able to make discoveries that then lead to a discovery in physics, the discovery of a new particle? How is mathematics able to do that? What is this connection between mathematics and the physical world? And I remember this striking me when I was a research student, not at the level of Peter Higgs for sure, but I do remember doing these calculations. I was working in mathematical physics and atomic physics and doing these calculations. We were using computers to solve the equations. And when we would run these calculations, we would get these answers coming out and they would correspond to the energy levels of atoms. So for example, the energy levels of the helium atom. And one day this just struck me as amazing, that I would sit working on the mathematics, running these codes, generating these results, and it turns out that these results correspond to the energy levels that have been measured experimentally. Why does the world work that way? Why is it that mathematics is so useful at describing the physical world and incredibly precise as well, that these energy levels can be worked out mathematically to a great degree of detail that is later confirmed experimentally? Why is it the world is like that? Well, according to Galileo, the universe is written in the language of mathematics. Philosophy is written in this grand book, I mean the universe, which stands continually open to our gaze, but it cannot be understood unless one first learns to comprehend the language in which it is written. It is written in the language of mathematics. So in fact, when we study mathematics, we are studying the language of the universe. And so just as we want to understand other human languages, we need to put a lot of work into them. If we want to understand how the universe works, we need to learn the language in which it was written. And for Galileo and for others, this of course raised the further question, who had written nature this way? Who had written nature in the language of mathematics? And as we'll see in the last part of the talk, their answer to this question was God. God was the author who had written language in this written nature in this language. And so when we're studying maths, we're actually studying not just the language of the universe, but according to this view, the language that God used in creating and designing the universe. But anyway, I'm getting ahead of myself. We've got this question as to why the universe is like this in the first place. Here's a further point about this, and I'm going off on a slight tangent, but it's a good one, and it's another Nobel Prize winning physicist, Paul Dirac, who said that it's more important to have beauty in one's equations than to have them fit experiment. So when people have been using mathematics and physics, they have often looked for beauty in their equations, not just trying to come up with equations that will sort of work, but that are in some sense beautiful. Now, I know for many people the idea of mathematics being beautiful might sound puzzling at best, but for mathematicians this is often the case. There is a simplicity or symmetry about the mathematics they're using, or an elegance to it that can be described in terms of beauty. Or sometimes the proof of a mathematical theorem is very elegant, and so it could be described as beauty. But again, why would beauty be a useful insight? I mean, okay, it's nice to have it. It's nice if your equations are beautiful, but why would looking for beauty in mathematics be a good guide as to the way the world works? So that's a related question. Let's now bring this together, but also think about a couple more aspects related to this. So Roger Penrose, a leading mathematician and mathematical physicist who has made himself many breakthroughs in mathematics, describes three worlds and three mysteries. So these worlds are, down at the bottom right here, we have the physical world. Then we have on the left the mental world, and up at the top the mathematical world, which he describes as in Platonic terms. So he would be a Platonist. He thinks that numbers and mathematical entities really exist. So we've got these three worlds, but there's a relationship between them. We've already described number one here, that mathematics, there's this link between the mathematical world and the physical world. So the first mystery relates to number one. Why is mathematics so useful in describing the physical world? Okay, so what's the relationship between those two? Secondly, then, we have a mystery as to the relationship between the physical world and the mental world. How does the mind arise from the physical? Okay, our brains, our physical stuff, but how does the mind come from the physical? Is that all there is to the mind? Well, that's a huge question in its own right, and so I'm going to ignore that mystery number two in this talk. But we also have a third mystery, and that is how from the mental world we can comprehend the mathematical world. You see, if this mathematical world exists in the way that Penrose is talking about, how is it that we can comprehend, use our human minds to comprehend this mathematical world? And so we have three mysteries. And so far we have looked at mystery number one. Why is mathematics so useful at describing the physical world? But now we're also going to include mystery number three. How is it that we can use our minds to comprehend this mathematics that is then used to describe the physical world? And so on this last point, it's not just Penrose who mentions this mystery. We also have Albert Einstein, yet another Nobel Prize winning physicist. He says the most incomprehensible thing about the universe is that it's comprehensible. So again, it's just the same question. How is it that we, with our human minds, are able to comprehend the nature, this mathematical nature of the universe? Here I want to suggest that atheism runs into problems with these two mysteries. First of all, let's consider the relationship between the mathematical world and the physical world. If we take Penrose's view of this mathematical world consisting of these mathematical entities, numbers and so on, that exist outside space and time, that are independent of the physical world, why is it that they would be so useful at describing the physical world in such incredible detail? There simply doesn't seem to be any explanation. It's just left as a complete mystery. It's a happy coincidence that it's true, but there's no reason as to why, and no explanation as to why it's true. And furthermore, the idea that we as human beings can comprehend this mathematical realm, because we, in this physical universe, that we exist with our limited human minds, how is it that our minds are able to grasp this mathematical realm in order to be able to describe the physical universe? Again, that seems mysterious, especially when we consider that on atheism, we are the result of an unguided, purposeless process that didn't have us in mind. We are the result of this chance process. So why is it that our minds should be able to comprehend these mathematical truths? And even if you don't think of this mathematical world as existing in this Platonic way that Penrose does, the mystery still remains. Because of course we might say, well, okay, the physical world would have some mathematical description, but why such a sophisticated one? Why is such detailed, complex mathematics used to describe our world that requires so much effort to comprehend? Why is the universe like that, as opposed to having a very basic or simple mathematical structure? So, for example, Einstein had to go and spend time learning a new branch of mathematics in order to describe general relativity. And so here we see that there's still an explanation that's needed as to why our universe is like that, why our universe is described by such complex mathematical structures. And again, why we as humans are able to comprehend them. So, of course, we might try to explain it in evolutionary terms, but that would only get us to perhaps very basic mathematics that would be useful for our survival. But why would we be able to comprehend the mathematics that is able to be used in physics, the sort of mathematics that Einstein was working on to comprehend general relativity? So I think these mysteries remain if atheism is true. By contrast, from a Christian perspective, I think things make a lot more sense, because now we can explain why the physical world has the sort of mathematical structures it has. It's because the mathematical realm and the physical realm are linked by God. God has an understanding of the mathematical realm, and he is the creator of the physical realm. And so God was able to create the physical world according to the mathematical structures that he had in mind. And this doesn't really matter whether you think of the mathematical world as being this Platonic world that Penrose thinks of, or mathematics in some other sense. The key point is that God has created the physical world with these mathematical structures in mind. And so there is a link now between the mathematical and the physical, and that link is God's deliberate, rational creation of the universe. Well, what about the other mystery as to why we are able to make sense, why we're able to comprehend the universe and the mathematics that's used to describe it? Well, again, according to a Christian view, we are made in the image of God. I mean, of course, we are limited, vastly limited in comparison with God. Nevertheless, we are truly created in his image. And so using our minds as God intended, we are able to, at least to some extent, comprehend the universe that he has made, because he has given us this ability. He has created us to be, in some sense, like himself. And so when we do science and when we do mathematics, we are able to, in a sense, comprehend God's thoughts. As some of the early scientists said, we're able to think God's thoughts after him. And so if this is right, then The effectiveness of mathematics in describing the physical world, I would suggest, gives us a pointer away from atheism and towards the existence of God. The use of mathematics makes more sense in a universe that has been created by God. So I want to turn finally to the third part of the seminar on the scientific revolution. So how mathematics played a role in that, and in particular how Christianity played a role in it. So Peter Harrison is a world-leading historian. He also previously held the chair of science and religion at Oxford University, and so he has done a lot of work on the history of the relationship between science and Christianity. And of course, many people think that the two are in conflict, that they always have been and perhaps always will be in conflict. But actually, Harrison would argue that this isn't borne out by the history at all. I mean, it's not to say that there haven't been particular conflicts. Of course there have. But in general, when you look at the history, you don't find one of ongoing conflict. In fact, you find one where actually theological ideas played a very important role in the development of science. And this is particularly relevant in the context of what we're talking about today, because one aspect of this concerns the use of scientific laws to describe the universe. Because when we think about the development of the scientific revolution, a lot of it concerned the discovery of laws, scientific laws. But we might get a false impression, because if we think of it in that way, we might just think that these laws hadn't previously been discovered. But actually what was going on, Harrison argues, was that up until that point, people didn't really think about the problem in that way at all. They weren't expecting to find laws in the physical world. So a big shift in the scientific revolution was to go looking for laws. And Harrison argues that the reason that this happened was because scientists such as Galileo, such as Descartes and Kepler, Newton, they believed in God as the lawgiver. They believed that God had created the world in a law-like and orderly way, and so they expected to find these laws in the natural world. Basically, that the natural world operates according to laws that God had put in place. Before that time, people did have views about laws, but those views were based on moral laws, for example. And so the move here was to think about these laws. Yeah, perhaps there were still moral laws, that's not the point, but that there were also physical laws to be discovered. And so this was one of the key developments, not just the discovery of laws, but the idea that there were laws to be discovered. And this was motivated by theological beliefs. Now, related to that was the idea that these laws had a mathematical form, because God had designed them in that way, as we've just been talking about. And again, prior to the scientific revolution, that wasn't really the way of thinking about mathematics. So Harrison points out that going back to Aristotle, for example, and a lot of medieval thinking about the universe was based on Aristotle's way of approaching things. But according to that way of thinking, mathematics was just a product of the human mind. So mathematics might be useful. I mean, it could be used to describe things, but not to give a true account as to how the universe really worked. But these early founders of science, people like Galileo, Boyle, Newton, Descartes, and so on, they began to think about things in a dramatically different way. That mathematics wasn't the product of the human mind, but that mathematics came from God. That God had created the universe to operate according to these mathematical laws that he had in mind. It had been designed that way. And so they went looking for these laws, to discover these laws, these mathematical laws. And of course, the rest is history. And so when we study mathematics, when we study physics today, we're studying mathematical laws, and we just take these for granted, but they weren't always taken for granted. It was at this development in the scientific revolution when they first started to think of these mathematical laws and to look for them. And this approach was inspired by Christian theology. And so we find Johannes Kepler saying that the chief aim of all investigations of the external world should be to discover the rational order which has been imposed on it by God and which he revealed to us in the language of mathematics. So we have been looking at three different topics as to how we might think about mathematics and Christianity. And so in studying mathematics as a Christian, I would encourage you to pursue each of these topics further. So the first one is the most abstract one, and it's about these fundamental questions about the nature of mathematics. You won't be studying any modules on these topics, by the way. It's when we sort of step back and reflect on the subject that these questions arise. So I think that's definitely one to explore. But then in the second one, we've looked at this applicability of mathematics to the physical world. Why is the world like this? And I would suggest that the best explanation is because there's a God who created the world. This incredible effectiveness of mathematics is best explained by the existence of God. And indeed, because we are made in God's image, a Christian notion, we are able to comprehend that world. And finally, this historical aspect, of course, it's related to the second point, but it's also the history of mathematics and its relationship with science. When we look at that, then we discover that these mathematical laws were motivated by Christian theology and played a role in the scientific revolution. So I think it would be really interesting to go and explore all three of these areas. And so what I would like to suggest is that when we're studying mathematics, yes, like any other discipline, we want to study it for the glory of God. That's what we should do. That's our responsibility. But also we want to think about these specific topics. And actually maybe when we're thinking about mathematics, when we're studying it, we're actually thinking about the language that God has used in creating the world. And indeed, again, to quote Kepler and others, we, in doing mathematics, can think God's thoughts after him. On this final slide, I'll just point you to a few resources, some books. In particular, William Lane Craig has thought a lot about these topics and has written a book, God Over All. And so he looks at this whole question of the nature of mathematics and some other books on it as well. Craig also has some podcasts and various online articles on this, including a short one on God and the unreasonable effectiveness of mathematics. And the website I've been involved in, we have a short summary of the argument from maths in 7 quick points. So you might want to look at these. And there are different views on some aspects of this. So you'll find a range of views on some of these topics. So I'm not saying you should necessarily go along with every view that you come across in these resources, but they will provide you for some resources to explore these topics a bit further.